Welcome everyone to the fourth lecture of the day with Joel Chen, who's going to be presenting Candid, the language of the internet computer. Feel free to start the presentation, Jan.
Okay. Hi, everyone. Welcome to this session. So I'm Yan. I work from Dfinity. I work on the languages team, and I mainly maintain the Candid language. And also I also maintaining the Motoko playground and IC repo. So in this talk, I will be talking about Candid. It's kind of the communication language for the internet computer. And I think the first question people may have is why? Like, why do you need yet another language? And I think the main thing Candid want to address is how do you maintain interoperability between different microservices? So for example, the canisters are kind of microservices that's running on the blockchain. And there can be many canisters running on the IC. And these canisters can depend on each other. They may send messages to another canister and they may expect a return message from them. And the difficult part is that all these canisters are independent. You don't control all of them, but you do depend on their service. And then if some of the canisters, say this green one, decides to upgrade their wasn't code, then all the canisters that depend on this canister can potentially be affected. Maybe they made a breaking change, then the canister that depend on you will no longer be working. And what's worse is that in the blockchain space, maybe some of the canisters are immutable. After they deployed, then they never upgrade the interface. So they cannot really upgrade with you changes. And we want to be able to allow this independent development of different canisters, but still allow you to not breaking other canisters while you are upgrading your own service. So that's kind of the design goal for Candid and why it exists. So the first item to support the interoperability is that we want the API, the canister API, to evolve without breaking existing client code. So for example, this is two snippets of code. The first one is written in Motoko. Suppose this is a canister that we are writing. And here we are defining a profile type, which has a name field. And then we have a query method of getting profile that takes an ID and then returns a profile back to the user. And suppose now there's another canister that wants to use this Motoko canister. And it doesn't have to be written in Motoko. It can be, for example, in Rust in this case. So in their canister, they basically define a Rust data type that is equivalent to what you define in the Motoko word, where basically it's a profile struct and it has a name field. And then you can import the Motoko canister as a remote canister and calling the canister method get profile. And then because it's you can await for the result and project out the name field from the profile. So this we need a kind of a language independent way to support different languages that are talking to each other. And another thing we want to support is that, for example, if the Motoko canister decides to upgrade, and then the Rust code without any change to the Rust code, the client should still be able to talk to the new Motoko canister without upgrading their interface. For example, in this case, the Motoko canister decides to upgrade by adding a new age field in the profile. And then also we decide to remove the input argument. Like maybe we have some other ways to fetch the ID, but by maybe using a caller's identity. And then basically we change the interface of this method, but we want to be able to, for the Rust canister to still able to get the same result even though the Rust canister doesn't know you have already upgraded the interface. And in the case of this example, this upgrade is actually not a breaking change because in the Rust canister, although the new version removed the ID field, but I can still send extra information to the Motoko canister. And this ID will just get ignored by the receiver. And then on the other hand, if I add a new field into the return type, but although in the Rust code, I only need the name field. So I can take extra information, but still able to project out the information I needed without upgrading my own code. So this kind of feature, which is specified in the Candid spec, we call it the subtyping relation, where it specifies what kind of upgrade you can do to make sure that you are not breaking existing code. And we're not going to the detail about the subtyping rule, but you can check out this link if you are interested in the more details. So overall, basically, to support the interoperability between microservices, you want to have a subtyping relation that allows you to safely evolve the canister code. And another aspect is that it needs to be language independent so that services written in different languages can talk to each other. And this is basically any serialization format can work. We designed a serialization format specifically for Candid, but in retrospect, you could use any other serialization format if you just want to transfer messages along the wires. For example, protobuf or JSON or anything, GraphQL you are using could work for across languages. But what's unique about Candid is that we define this strongly typed interface that allows you to safely upgrade the interface without breaking other services. So as an overview, that we can see that Candid is kind of a strongly typed interface description language. And for the previous slides, we see the Motoko code for the method. And then this is the Candid description that's extracted from the Motoko code, which basically says that you define a profile type, which is a record, and then it has a name field. And then for this canister, you have a service of a method called getProfile, which takes a net and then returns you a profile. And because it's a query method, we have a notation here saying this is a query method, not the update method. So this is the first version of the canister. And then the upgraded version is basically removing the input argument and adding the new age field in here. And also we notice that this profile or the type name is just not essential in describing the interface. You can choose to inline this whole record definition into the method directly without giving it a name. These two will be equivalent. And in terms of the serialization format, we encode the type information as part of the wire format. And then because you have types on the wire, and then you have the types at the client side. So there are basically two types in the decoder. When you receive a message, you get this type on the wire, and then you want to convert that wired type into the expected type. And this allows you to not just working on exactly the same type match, but allows you to decode a subtype of the original one. So for example, in this graph here, the blue one is the client code that only knows the first version of your canister. And then this green one is the new canister after the upgrade. So this is the real canister we're talking to, and the client only knows the old interface, which is the first one. shown here. So for example, the client can send a message which contains an ID, but the new server is already removing the argument. So it will decode this 42 number as an empty argument. And this is allowed by the subtyping. We can easily drop the extra information. So this will be a success decoding. And then after decoded, the get profile method will send back a return message, which contains the new field age, because we are with a new interface. And then the client doesn't know you can turn a new field called age. It only knows expecting that you have a name field here. And then this age field becomes an actual information. It gets thrown away, and we are safely decoding this new version into an older version. But in contrary, if the profiler or the server is sending a record that only contains an age, then this will fail the decoder because I'm expecting a name field, but it's missing in the message. So this way, it allows you to safely upgrade the interfaces when it's obeyed to the subtyping rule. But if it's done, you are sending some message that is not allowed by the subtyping rule, it will detect the error and tell you exactly where this is going wrong. So in general, like a Candid is kind of sits in the middle of the IC, where it connects between the front end and the back end. So in the back end, we basically have mainly have Rust and the Motoko canisters, and they both understand the Candid, and for Motoko, you can either export Candid type into export Motoko type into Candid, and you can also import other canisters from a did file into a Motoko type. But for Rust, for now, we only support exporting Candid file, and it's kind of a menu. So we're working on improving the support for Rust at the moment. So that's why it's kind of a red working area. And then on the front end side, it all understands the Candid file. It doesn't need to understand anything about the underlying implementation, whether it's written in Motoko or Rust. It feels the same to the front end. The front end only cares about the Candid file, which is the interface this canister have. And we have CLI tools like DFX or ICRepo that can understand the Candid type and can send messages to the backend. And also for building front-end apps, you can, starting from a did file and generate a JavaScript binding. And then from there, you can send messages to canisters as well. And also we have something called Candid UI support that I can show in a moment, where you can generate UI based on the types directly in the browser. So that gives you another way to communicate with canisters. And to understand this better, let me give a demo about how this works internally with the default grid app. So here I basically create a new DFX file project that is just the default project. It's called test, and then it has a great method, just a default app. And if I call DFX deploy, it will basically generate all these Candid files and then integrate them into the front-end app. And the files we're generating is located here, the .dfx local canisters. And inside the project, we can see all the build artifacts. So for the grid example, we can see that this canister has only one method called greet that takes in text and returns a text. And this is auto-generated from the Motoko program we provided. And also for the front end to work, we basically convert this did file into a JavaScript file, which is this did.js file, which is kind of equivalent of the original did file, but with some JavaScript bindings. Basically, this service becomes a service class in JavaScript, and it contains multiple fields about each method. Here's the method name, and each method name corresponds to a function class, which takes a set of input and a set of output. And the last one is a function annotation, whether this is a query method. If it's empty, then it's update method. So by having this function, this JavaScript function, then the front end can work with can understand the Candid type and sending appropriate messages to the target canister. So we can also take a look at the source code here. This is the front end code, and see how this JavaScript binding works in the front end. So basically, when you run dfx deploy or dfx build, it will generate a new directory called decorations, which basically copies all the build artifacts of the Candid file, like the did file, did.js file that we just saw, into this decoration directory as part of your GitHub commit. And I think the reason we do this is because it makes some IDEs to be able to pass the type information in the IDE more easily. So basically, if you want to talk to a canister, for example, the test canister, then you can just import this test.js file from the decoration directory. And then the way you call it is this simply an object. This test is simply an object that contains all the method you have, and you can call it just like a normal function, like test.greet, and then having a string as the input, and then you call await to get the final result. So it's a pretty ergonomic or feels native to JavaScript, where you can just import the canister and call them directly as an async function. And also in this link here, we show all the type mappings between different languages. Like for each Candid type, how do they represent it? What's the corresponding type in Motoko, in Rust, and in JavaScript? And how do we represent them as a value or in the text representation? So you can always look into different types and see how they map to this. Another thing is with Candid is the DFX supports Candid directly by using canister call. So we have a greet method, and then this method takes the argument, and the argument format is actually in the Candid texture format. So for example, if I pass in a test, that's the syntax for the string, which is double quoted, and then we get the result also in the Candid representation. You can also look for the syntax here. For example, the texture representation for Candid is just a double quote, and it also supports like escape of Unicodes. Okay, now let's go back and see in detail exactly what kind of types we support in Candid. And first of all, there are several primitive types. There are kind of number type and with nat and integer. And these are infinite precision numbers. And then there are fixed with integer types. And then we have float 32 and float 46, Boolean type, text, and then null type. Reserved type is something like in protobuf where you want to upgrade, you want to deprecate a field, and you mark this as reserved so that future messages using the old field will get dropped. And empty is kind of there's no value of an empty type. It's really just an empty type. And you can define names for these primitive types. And this allows you to write the recursive types, like defining a list where the head is a number and then tail is the type itself by giving it a name. And there are also more complicated constructor types like option type, which is either a null or a value of the data type, or you can define a vector type, which is an array of the same value. And then there's also a record and variant type, which we can see from here. And so basically record and variant are specified as a number, a hash number as the field name, and then the data type. And then syntactically, we allow you to specify using name as field, but eventually in the representation, we have a hash function to convert this string into the hash value. So that's why sometimes you see when you are using DFX to call a canister that doesn't export the Candid interface, then you get some record with some numbered field there instead of the real name, because we do this conversion before serializing the message. And also we support some shorthand, like for record, you can either say this record starts from index 0 and then 1, but you can omit this index if it's just a tuple, if the numbers are consecutive and starting from 0. And also for variant type, if the variant type has no associated information, then the type is null, so you can omit them. And this variant type becomes an enum, like you can have different tags and the tag contains no extra information. And finally, we have reference type, where allows you to send principal ID to the canister, like your identity, or if you are calling to another function or another service, this will become also a canister ID that allows you to send over across the wire. So, and finally, the integration between Motoko and Candid is we try to be as seamless as possible for this integration. And the goal is that we will be able to round trip all the Motoko values of shareable type. And by this, we mean that when you export, you can either export a Motoko type to a Candid type, or you can import a Candid type to a Motoko type. And then for all the Candid types that is in the domain, we expect or we require that the import of this Candid type to the Motoko, and then you export them, you get the original one. That's kind of the identity we are maintaining throughout the whole translation process, but not the other way around. We like if you are exporting a Motoko type and then import it into Candid, we don't guarantee that will end up with the exact type. We will show this in the next slides, like why that's the case. And then for export, you can call the Motoko compiler with the -idl flag, which will basically generate a full .dit file that that basically extract the interface from the Motoko code. And by import, you can, in Motoko, you can say import canister colon canister name. And this name has to be appear in the dfx.json file so that you can know the dfx will tell you the canister ID of this canister. And then inside the Motoko, you can just use this as a regular module where you can call different methods defined by the date file. And now this is a more advanced topic, which is the type gaps between Motoko and Candid. And as we mentioned earlier, that the import and export are not symmetric. So here's the more detail of exactly where the asymmetry happens. So some of the Motoko types can be exported. For example, if it's a mutable type, then it cannot be exported. And if the Candid, also on the other side, some Candid type also cannot be supported in Motoko. For example, Motoko only have floats 64. And if you import a canister that use floats 32, we will trap because we don't support that in Motoko. And another thing is the character type in Motoko. If you export the character type, then it becomes a net32 type in Candid. But if you import a net32, it will be a net32 type in Motoko, but it won't be a character type because not all value can be converted to a character because of the Unicode encoding. And another thing we don't support in Candid is polymorphic types. For example, if you have a result type of T and T1 and T2, that won't work. You have to give a concrete type for them, and then we can convert them into a variant. Like this result type will become a variant type with concrete types. Another exception is like if you import a Candid record field in which the field name is a reserved word, like if it's an if, which is a reserved keyword in Motoko, we will add underscore here to be able to, for Motoko to pass it. And then if it's a number, then we get two underscore in between the numbers. And also Candid supports Unicode function names. So you can call this, define this call method in Candid, but when you import them into Motoko, it becomes a number, which is the hash value of this Unicode number, Unicode name. And you can still call this method in Motoko, but just use this hashed name instead of the original Unicode name. Another difference is that in Candid, blob is a shorthand of vector of net8. But in Motoko, we distinguish these two types. So if you import a blob type, it becomes a blob type in Motoko. And if you import a vector of net2, it becomes an array type, which is slightly different because we kind of have a more efficient implementation for blob. If you're handling larger data, then blob may be a better way to do this. And also another new feature we recently released in the latest DFX release is based on the Candid interface, we are able to check the upgrade safety of your canister so that when you upgrade the canister, we are able to check if this upgrade is safe or not, with whether it breaks the existing code. So I can give a demo for this. Let's just use the great example. So because I already deployed an old version, now let me try to upgrade by saying I want to change the method name of this function, and I can call redeploy. Now DFX will detect that okay, this upgrade is a breaking change because the original method has original canister has the great function, but this is now missing in the new canister. So if other canisters are calling great, it will fail. So it basically checks whether this interface change backward compatible or not. And of course, you can override this by saying yes, and then it will still deploy. But knowing that this is can be a breaking change. Another safety check we do is for stable variables. So for example, if I define a counter as a integer type, this should work. I can always add new stable variables in the upgrade. And now if I'm changing this type in a not compatible way, say I change this int type into nat, this may cause information loss because integer type may have negative values. And now you're changing to nat, so we have no way to guarantee that the information will always be preserved. So if I do dfx deploy here, it will detect that, okay, the original stable variable of counter is of int type, and now you are upgrading to a nat type, which will cause data loss. Because in this case, if the subtyping checking failed, dfx will reinitialize the stable variable value so that the value you previously stored will be lost. And this is the check to prevent this kind of data loss. So if we say no, it would abort the upgrade. And the way this works is basically in DFX, when we generate the date file, we also embed this date file into the Watson module as part of the metadata. And then the replica will expose this metadata as a HTTP endpoint where DFX can fetch this metadata on-chain. And then we can compare the on-chain metadata with the new build, whether they are compatible or not. So we can actually see this from the Watson file. So let me see. This is the generated Watson file. If I see the headers, then I can see there are some custom sections here being generated. And in the spec, we basically say, if you have a prefix with ICP colon, and then either it's a public or private, we will create an HTTP endpoint for this canister with this name. So this name is hard-coded. It will store the Candid interface into this this custom section, and then this is the initialization argument for the canister. This one is the stable variable type that we just see when we change the counter type. And the private means owning the controller of this canister can see these custom sections. And if it's a public, then everybody can see it. So we can go further by inspecting the custom section of, say, the Candid custom section. I think it's maybe S. Yeah, this gives you the full information of this custom section. We can see it's basically the Candid interface service. Yeah, this is the content that can be fetched from the replica. And finally, so this Candid is kind of the middle where you can talk to other canisters, and also even DFX deploy. If you see what's under the hood of DFX deploy, it's actually just a bunch of Candid calls to make sure to deploy the canister. So we built a tool called IC REPL that allows you to interact with IC interactively in a REPL environment where you can just call this system or other canisters from the REPL environment. Let me give a demo about that. So this is talking to the local replica. You can make any method canister calls by having a keyword call, and then IC is kind of a special canister ID called the system canister. That's actually equivalent to this. Did I miss it? Okay, maybe that's. And then if you press tab, it will basically try to autocomplete the method, like showing all the methods this canister have and their Candid interface. So it gives you an easier way than DFX canister call to fill in the information you need. So for example, if you want, the way DFX is calling deploy is actually by calling this system canister with a method called provisional create canister with cycles. And then here we generate some random values based on the type of this, this input argument. Every time you change it, it generates a new random value. But here, let me try to. So this setting is an option field. Let's just use the default one. No. Okay, now after calling the create canister, the system returns you a new principal ID. And then with this principal ID, you can install canisters on it. Let's find this ID. So this underscore means the previous return result. So I can bind this with the canister ID. And then if I say ID, it will become the return value of this canister. Then I can call install code, which basically installs the Watson module into the canister ID that I just requested. So I can say this is the ID, and then this will be the Watson file. That will be DFX local canisters test.watson. And this will be an install. So the argument is the initialization argument for this canister. Like in Motoko, that means if you have an actor class, then you can define some input argument, and this will become the Candid encoding of that input argument. And here, because we are just using actor, so it's an empty argument. Okay, now after doing this, it will succeed, and then I can call ID, which is the canister ID we just defined, and it automatically recognize we have a method called grade2 and generates we can call this as usual because we just installed this Watson module there. And I can also we also add a new command called fetch that allows you to access the HTTP endpoint of the canister. Say I want to fetch this ID of the, let's say, module hash, I think. Yeah, then I get this is basically calling the HTTP endpoint of this canister and fetching the module hash. And then if we can also see the Candid interface by calling metadata and then Candid service. So this will be the Candid service. This is exactly how DFX fetch the meta information from the canister. And also you can call, I think here it has a canister status, yeah, of the canister we just installed. With this ID. And then you will see various status of this canister, like it's currently running, the memory size, cycle, also the module hash here. So we have some example code for the IC repo, and this whole repo also supports functions. So you can wrap everything we just showed into a function. So for example, here we define the deploy function, which is essentially calling the create a canister and then install code. And it takes an argument where you can just say deploy and then the file. Then you would do the equivalency of DFX deploy. And we also support identities where you can specify different identities, like randomly generated ones, but it's named. So then you can later refer to this name. For example, I'm deploy the canister using Alice as identity. And then after I call in the canister status, I should be able to assert that the status setting has a controller, which is Alice, because I installed using Alice as an identity. So this also, with these assertions, it also gives you a nice way to write end-to-end test about the canister. After you deploy, then you can call the different method using the script, and then you can assert different properties about the value. And we actually have an example about this. So this is recently the DAO example we built. Basically, it mimics a minimal version of the NS canister, a very simplified version of NS canister. And we have both implementation in Motoko and Rust, which is in the example repo. And for the Motoko version, I wrote a test in IC repo. So this prelude is basically the deploy function that we just saw, like how you install a wasm code with argument and with specifying cycles. And then if you load them, then later you can call like the install method, which is defined in the prelude. And then here is, yeah, that's one tricky thing, is that in the DAO example here, it's using an actor class. So it has some initialization argument when you deploy the canister. But in order to get that type, you kind of need to define a fake canister ID to associate a did file with them, so that you can encode using this this canister ID and then the init archetypes. Then you can encode them into the right type. So using this trick, we are able to pass the initialization argument into the install. And this is a very simple test. It basically set up a bunch of accounts with different identity. For example, I set up initially it's Alice, and I give, in the initialization, I give Alice token of this amount, and then after the install, I can call this canister and check the balance, because my identity is still Alice, so I should be able to see the token that is initialized here. And then if I change to another identity, I call the same account balance, I should get a 0 balance. And then I can initiate the transfer of tokens in different accounts, saying, for example, Bob wants to transfer to Alice this amount of token, but since we have 0 balance, so we will see an arrow saying this account needs, it needs an account to transfer the fund. And if we now switch to Alice, then the transfer will succeed. So we can track the final amount using the assert. And we can also test for the upgrade. For example, here I can call the upgrade, which is essentially the same install code system method, but with a variant upgrade. So after the upgrade, I should be able to check that the original amount is unchanged after the upgrade. So you can test really the upgrade preserves the data you need. So I think this is kind of a nice way to play around with the IC and also writing tests. You can also, by specifying a different replica, for example, you can say a replica to IC that talk directly to the mainnet, and then here you can talk to any canister that's live in the mainnet. For example, the NS canister, you can get all the maybe current pending proposals. It will give you a list of them, and if it's too large, then I can say tab, and it tells you currently this array has it has 4 pending proposals. If I only want to see the first one, I can show the first one, and then it basically shows all the field it has, and I can dive in. Like I want to see the proposal. Yeah, so you can basically extract out the information from the return as you want, based on the types. Yeah, I think that's all of my talk today. Now it's the question. Any questions? I'm happy to take it.
So I have a question. I was wondering, it was a bit before, so like 15 minutes before, I think, when you talk about the metadata of the WASM module, I think. So basically, I'm wondering like how the FX knows that the interface changes will break. I understand. No, sorry, I understand the interface. Like if you change the interface because you have it available, but I don't understand how the FX knows about the type of the stable variable.
Yeah. So that's another file that I omit. Motoko compiler actually emits 2 build artifacts here. So if you see, there's the did file which specifies the interface, and there's another file called most. I forget why it's called most, but this is the type signature for the stable variable here. These are also stored in the WASM module. And DFX is fetching both to check if both of them are obeying the subtyping rule.
Okay. It's just that we don't. I've never seen the.
Yeah. This is very new. Yeah, this is very new. Yeah, we just roll out in the I think 09.2 version that supports this.
And Yeah, I might have a second question. I think you've talked about the field reserved in when you were showing like the Candid types.
Yeah.
I'm not sure I understood what that meant exactly.
That's kind of in the upgrade. So I can, let's say you have an old did file. Which has a record, maybe maybe int and that. Like this. And then in the new version, say you want to deprecate this first field, you can say this is reserved. Now, if the old version is still sending you an integer, then the new version will just ignore this value. And this will be a compatible change. We have a tool called dipsy that's in the Candid repository that where you can check if these two interface are compatible or not. So for example, this will pass the compatibility check. And this is exactly the code that DFX is using to check for compatibility. And for example, if I
imagine we have a service like so this one, and so the controller of the canister is going to change one of the field of the record, and is going to change from int to reserved.
Yeah. But, right. So this is allowed. The reason is that you cannot delete canisters. You can't delete field. So originally it's like this, right? And and if I choose to delete it, reserve is like a deletion, but it's actually reserve a position there. So if I want to do the deletion, then I will see an arrow here. It will say that this is not allowed because that original position is taken, right?
Yeah, because sorry to interrupt. I'm trying to understand. Right now, it's not possible because like the client, if someone like is trying to call this service, there is like a int and a nat. So if you just like delete the two, one of the two, the client will not like it. So it's not possible. But I don't understand like reserved. I mean, if someone is expecting an int.
Yeah, so reserved means it can expect anything, any value. It just ignores it.
Okay.
So this is basically a tuple. Like you have two positions. The first position has a value, and then the second one has a value. If you delete them, then the tuple becomes only one value, not two values. So I'm using reserved to say that I want to ignore the first one. Which is equivalent to deletion, but we don't allow you to delete that. I just reserve this. I keep a position live here, but I just don't care whatever you send me. It will be ignored.
Okay, thanks.
So this is like a deletion, but in most cases we don't allow deletion.
Yeah, this is like saying like something, but I don't care. Like what is this exactly? Like it's just a tuple and there is something else. Okay, got it.
So you can send any type to a reserved type.
Guys, if you have questions, please raise your hand. Go ahead, Alejandro.
Hey, hi. My question is, if I had to talk or send message to another canister, how I can know what is the candid? What's the role of the canister from my code or from an external canister? Basically, what I want to do is to check if the canister does what it's supposed to do.
Mm-hmm. Yeah, so there are several ways. One thing is you look at the Motoko code and you see the public functions. Each public function becomes a method in the did file. So you can see directly what type they expect, what's the return value, or you can see from the did file, like I think it's in the declaration of the did file that says the exact candid type of this canister.
But they are mine canisters.
Oh,
but
you mean like other people's canister?
Yeah, you create a canister. Mm-hmm. It says, okay, this canister is this for, and it applies this rule. Well, I would like to see your candid file to make sure that you have all the functions that complies.
Right.
So yeah.
Yeah, for remote canister, we're just getting started. The starting point would be the fetch interface, the HTTP endpoint I just showed in the IC repo. So currently DFX doesn't support fetching remote canisters, but eventually all the canister will have the did file as part of the Watson module. And then if you fetch the interface, you can basically see the candid interface of the remote canisters. Okay, so currently, either you want to provide the did file manually. I think there's a recent DFX release that allows you to do this, but it's kind of manual. Eventually, we want to support like automatic extraction of remote did files. Yeah, this remote canister support, like basically in your dfx.json, you can say this is a remote canister and this is the candid type of this canister. And then in Motoko, you can say import canister that this canister name as usual.
Oh, okay, so by importing that, I have access to all the functions.
Mm-hmm. Yeah. So the thing is, you need to know what did file is for this canister.
New file. Okay. How I know that? Is there any way to know that?
Either the author will publish it at the moment, or like, yeah, there's no public way at the moment, but we're trying to add support for that by just fetching the metadata from the Watson file.
Okay.
At the moment, it's somehow you need to know the did file, otherwise it doesn't work.
Yeah.
Okay, guys. We're gonna take 2 more questions because we have to finish the session. We have the Dev Mentor hour session in a few minutes. We have a question from Dan. He asks how to discover public API of a deployed canister.
Yeah, that's I think the same question we talk about here.
Okay.
Yeah.
Mark asks, what if your algorithm is not compatible? What do you do to save the canister data, or how would you restore that data?
Mm-hmm. Yeah, so if it's not compatible, you can just say no when you deploy. So this track is before you actually do the deployment. If you say no, then it won't deploy. Then you have a chance to change your code to make any changes to make this happy. For example, in this case, if you really want to change an int to a net, the way to do it would be to create a new counter. This will be a net, and then I think it's this function, because int can be negative. So you take the abstract value of the int. So this will be import of int. So then this will work because it preserves the counter value, and then after the upgrade, it fetches the existing value into the net value, and by calling the apps function. If you say deploy now, I think it will pass. Yeah, now it passed. And then after the upgrade, this counter becomes deprecated. So you can delete it. Okay, this is a bug. We have a fix, but not in the DFX, the current DFX version. Sorry, this should pass.
Excellent, thank you, Jan. We have
so if you one more thing is that if you are okay to lose your data, then of course you can say yes, and then it will just upgrade, but the data will be lost.
Okay, we have one more question from Alejandro.
Yeah, just quickly. How usually you audit a canister if it meets the standards, some standards? How you do that today?
I guess mostly just code review, and there are some guidelines of how you write canister safely. So one thing we do in DFX is to check at the interface level whether this upgrade is safe or not. But there are also in the code implementation, like more things to check. Like if you have a async calls, and then it becomes like after each await is basically a separate message. So things can change during the before and after the awake. So you need to be aware of this kind of corner cases and make sure the canister are really safe.
But we cannot audit our deployed canister. It has to be before.
Yeah, there's no like a fully secure way to audit this. Currently the thing we provide is only at interface level, like for candid interface and stable variable types. Mm-hmm. But you can still make mistakes. Yeah.
All right. Okay, thank you. Sorry for take you holding you.
Yeah, sure, no problem.
Anything else you want to add, Jan, before ending the session?
Yes, I will also be the dev session. If people have more questions, and feel free to ask me there then.
Excellent. Thank you very much, Jan, for this presentation. So see you all guys in about 20 minutes for Dev Mentor Hour.
Okay, bye.
Bye, guys.